Welcome to the seventh part of our lecture. I'd like to tell a few more things about DriveConstructor in this final part. DriveConstructor actually works in quite a simple way. So, of course, we need to do some preparatory work up front. The creators of the DriveConstructor course, so we worked with catalogs of real manufacturers of the equipment, like electric machines, frequency converters, and so on. And we produced, based on those standard catalogs, we just averaged information, and we got some average catalogs. And then when you go in and you specify what you would like to have from your system when you set up parameters, there is a sizing logic in DriveConstructor, like current of this component should be higher than current of that component, or like torque of this component should be higher than torque of that component. Based on this sizing logic, we pick up right component from the catalog, and you can see the system, and you can see then the chosen components in the final results in the outcome of the calculation. And of course, because the catalogs are simple and the sizing logic is simple, you get the results immediately. So there is almost no calculation time, you will notice. So what is quite special in DriveConstructor is first that you can analyze costs of the components and the system, because it's important to have cost included into any benchmarking of the systems alongside with efficiency, weight, footprint, volume, or whatever, because really cost is dominating in the real world. So when our customers are choosing system configurations, they will first look at the cost. And then what is also possible in DriveConstructor is to look at the efficiencies at partial loads. So we are not only talking about the rated load and the rated efficiency, but we can look at several points here and there in between. And what we can also do, we can benchmark systems on many parameters simultaneously, and we can visualize it. Like in this graph, we see that price is the same as cost. Price of one system is higher than price of the other system, and weight is also higher. So in this particular example, it looks like system number 2 is better than system number 1, because we can see that the efficiencies of the two systems are comparable, but system number 2 is more compact and just has low weight and low cost or lower price. So this is quite good for understanding the differences between the system. I think this is quite an important message, what you see on the slide now. It's the vision of the DriveConstructor as the initiative. So we think that actually when learning about and working with standard components from standard catalogs, you learn exactly the same things that you would learn working with special purpose-built or tailor-made components. So actually the logic of putting systems together is the same for standard components and special components which you would design from scratch. That's why we have this averaged catalogs in DriveConstructor. And we are not designing anything, we're just using things that are available off the shelf, we can put it this way. And we also think that when someone is working with our course, the knowledge acquisition will go faster than any other way of learning. It is faster than you would get just attending some course at the university, lectures and seminars with the teacher. Because here you can really try a lot of things very fast. In a matter of seconds, you can try different system configurations, and by this trial and error approach, you will learn very fast optimizing the systems. So if you also watch the video tutorials for the exercises and you really try in practice these exercises, you will sort of get a feeling of the system design. And you just in several hours can obtain the experience that a normal engineer in the industry would need like 5 years to obtain. So that's why we have the mission of this project as a faster knowledge acquisition. And a few words about how the exercises are made. So in each exercise there is a task, so what to do, what kind of system to design, and there will be parameters, things that are fixed, that are given, and there will be variables, things that you can vary, that you can try out, and there will be some constraints or some criteria. So what you are not allowed to do, what thresholds you're not allowed to cross, and what actually is good if you do this. So what are the criteria of goodness for your system? So I think all the exercises are following this principle described on this slide. The exercises in DriveConstructor are divided into two groups. Simple exercises, they are really not that simple, but simpler than the group number 2. So in this first group of exercises, you will learn, you will understand the components, electric machines, frequency converters, and you will understand how to put them together, also with the gearboxes to make the system. So, but you more learn about the components and the system design. But in the second group of exercises, you will be working more with application, already using the knowledge you obtained while working with the simpler exercises. So then you will make real system for pumps, for conveyors, for window type turbines, and for the winches. So I really recommend you start with the first group. The exercise is called EM, EM1, EM2, EM3, FC1, FC2, FC3. So they're easier to start with. And then after you're finished with them, you look at the second group of exercises, designated P1, P2, C1, C2, and so on and so forth. You may ask how my answers to the exercises should look like. And actually there is no defined format. You can just have a piece of paper and draw on this piece of paper and just note down dimensions of the systems, characteristics, efficiencies, costs, whatever. But of course, if you used Excel, for example, or Word documents to systematize the information, the answers, then it is better. Then in Excel, for example, you can have tables like this one, and you can have charts like this one. And then you, of course, can easily submit it to your professor. You can also make simple sketches just by hand or in PowerPoint like I did here, and then you can just paste these pictures into your answer to follow your tables and your calculations. So then it will be good visualization. Like for example in this example we see that transformer didn't fit into the container because there was a given length for the container, so you placed it outside with a purpose, and you just chosen their transformer with high protection degree. So things like that are good to visualize with drawings, hand drawings or PowerPoint or whatever format you like. Congratulations, you finished with the lecture. I apologize for all the imperfections in this lecture. It was supposed to be like a living lecture, but we had to put it online due to the circumstances, and I hope it was helpful in some way. And I really recommend you to start with DriveConstructor. Just go in and try it out and follow the instructions from your professor. If you have any questions or problems, please do not hesitate to contact me on the email address which you see on this slide. I wish you good luck with studying electrical power systems. I wish you good luck with DriveConstructor. And again, thank you for watching. I'm very grateful. Good luck and bye-bye.